Okay, so in this example, we're going to be solving the equation k squared plus 12k equal to 13 using the quadratic formula. In order to solve the equation using the quadratic formula, we need the equation to be equal to 0. So I'm going to subtract 13 from both sides, so that will be equal to 0. We can't combine that 13 with anything, so we'll have k squared plus 12k minus 13 equals 0. Next, in order to actually use the quadratic formula, we need to identify what a, b, and c are, coming from the standard form of the quadratic equation. A is always beside the variable squared. In this case, there's nothing beside k squared, so it's implied to be 1. B is always beside k to the first. In this case, it's 12. And c is always by itself, which is negative 13. Something important to remember is that it's not about the order, it's about what it's connected to. So ax squared plus bx plus c is standard form, but you don't always have all three of these numbers. So to make sure to identify them correctly, remember it's about what it's connected to and not about the order that it's actually in. So now that we have identified a, b, and c, we can go ahead and use the quadratic formula. The formula itself is x equals, or in our case, because we have a different variable, k equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So now we're going to go and just substitute in a, b, and c into the quadratic formula. So we have negative b, which is 12, plus or minus the square root of b squared, so 12 squared minus 4, which is part of the formula, times a, which is 1, times c, which is negative 13, all over 2 times a, which is 1. I always recommend writing the initial setup down for the quadratic formula because it's very easy to make a mistake going through it. And if you write the initial setup down, it usually helps make it easier to find some of those mistakes. Oftentimes they are just writing the wrong number down or forgetting a negative sign. So writing the initial setup down can be very helpful. Now, the next thing I usually do is I simplify 3 different parts of this. So negative 12 in this case really doesn't change. We just get rid of the parentheses. Sometimes, however, it's a double negative, just not on this example. The next thing I deal with is the stuff underneath the radical. Usually I might just type it into a calculator, just the stuff underneath though, not the radical itself. Algebra 2, you often can't type the radical itself in because either complex solutions or you would get a decimal, and we usually use exact answers in Algebra 2. So I would just type into my calculator 12 squared minus 4 times 1 times negative 13. Or you can just do this by hand. 12 squared is 144 minus typing this in. Well, I guess since there is a negative there, it's going to be a plus 52. And then 144 plus 52 is 196. So 196 will go there. And the third thing I always handle is dealing with the denominator of the fraction. 2 times 1 is 2. Okay, so after this, I need to continue simplifying the expression. Usually the next thing we'll have to deal with is this. Oftentimes in Algebra 2, that's not a perfect square, so we would have to break it down. However, in this particular example, it is a perfect square, so we're going to have negative 12 plus or minus. The square root of 196 is 14 all over 2. Because it was a perfect square, we are going to separate things and continue. Remember that there are 2 different answers because of the plus minus sign. So we're going to separate into the 2 different answers, negative 12 plus 14 over 2, and negative 12 minus 14 over 2. And just continue to simplify. We'll have 2 over 2, which is 1 as one of the answers. And then negative 12 minus 14 is negative 26. Divided by 2 is negative 13. So these are our two answers. Okay, in this example, we're going to be solving the equation 9x squared equals 11x using the quadratic formula. In order to use the quadratic formula, the equation must be set equal to 0. So I'd like my x squareds to be positive, so I'm going to move everything to the left side here. However, it doesn't actually matter which side we move it to. So I'm going to subtract 11x from both sides. And I don't have any like terms that I can combine, so it's just going to be 9x squared minus 11x equals 0. Now, in order to actually solve using the quadratic formula, I need to know what a, b, and c are. A is the coefficient with x squared, which in this case is 9. B is the coefficient with x, in this case is negative 11. And c is the number without the variable, which in this case we don't have a number without the variable, so c would be 0. So we now have a, b, and c, so we can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I will plug in a, b, and c, and then just continue to simplify. So b is negative 11, so we have negative from the formula, and then the negative 11 from the actual b, the plus minus sign, square root of b squared, so negative 11 squared minus 4 times a, which is 9, times c, which is 0, all over 2 times a, which is 9. We can go in through and simplify the different pieces, and I always do the same three things. I deal with this. Double negative is a positive 11. We have our plus minus sign and our radical. Next thing I deal with is the stuff underneath the radical. I'll type this stuff into the calculator, or I'll do it by hand. I'll type it in exactly as I'm writing it off to the side. Just don't type in the radical. In Algebra 2, that's often going to be imaginary, so it won't work out if you type it in the calculator. In this case, though, it's not imaginary. 0 times this stuff would just be 0. And negative 11 squared is positive 121. So 121 minus 0 is 121. And the last thing we have to deal with is the 2 times 9 in the denominator, which is 18. Then we just finally look at the radical. This radical is actually a perfect square this time. The first examples I was doing were recap from Algebra 1, so they are indeed perfect squares. Square root 121 is 11 over 18. Then because it was a perfect square, we can break this apart, and we'll actually be able to combine like terms. So we'll have 11 plus 11 over 8, and 11 minus 11 over 8. 11 plus 11 is 22. Divided by 8 wouldn't be a whole number, so we'll reduce it as a fraction. The number that goes into both 22 and 8 evenly is 2, so we'll divide both top and bottom by 2, canceling out that common factor, leaving me with 11 over 4 as one of our answers. And for the second answer, 11 minus 11 is 0, and 0 divided by 8 is still 0. So our two answers is 11 over 4 and 0. Okay. Now, the discriminant is a formula that basically just tells you how many solutions and of what type a quadratic equation has. Now, this just comes from directly from the quadratic formula. The quadratic formula being negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula. And this tells you what are the solutions. The discriminant, it tells you something different. The discriminant tells you how many solutions. And not what they are. It just tells you how many there are and what type they are, not what the solutions are. If you look in the quadratic formula, you can see the formula for the discriminant right here, the b squared minus 4ac. That tells you how many solutions there are, because when the number underneath the radical is a positive number or greater than 0, it will have two real solutions, while if it's equal to 0, the square root of 0 is itself, and plus or minus 0 would just be 0. So if the number underneath the radical is 0, there will only be one solution, because positive square roots of 0 and negative square roots of 0 are the same thing. And then if the number underneath the radical is less than 0, then there won't be any real solutions, because you'll be trying to square root a negative number, which we can't actually do. Instead, we'll have two complex solutions, which are solutions that contain both imaginary and real numbers. So in this example, we are asked to determine how many solutions, not what they are, how many. So we're asked to determine how many solutions this equation has. Because we're looking for how many, we want to look at the discriminant, the b squared minus 4ac, which is the part of the quadratic formula that's underneath the radical, and also determines how many solutions there actually is. So just figuring out a, b, and c, first of all, it has to be equal to 0. In this question, it is already equal to 0. A is beside x squared, b is beside x, and c is the constant term, so c is 5. If we plug a, b, and c in for the discriminant formula, we have b squared, so 12 squared, minus 4 times a, which is 2, times c, which is 5. We can either type this in or do it by hand here. We have 12 squared, which is 144, minus 4 times 2 is 8, times 5 is 40, and 144 minus 40 is 104. Now we have to compare this. Is this greater than 0, equal to 0, or less than 0? We compare this number to those three options. Well, in this case, 104 is greater than 0. Because it's greater than 0, that means we will have two real solutions. Since there will be a positive whole number or a positive number underneath the radical, it creates two real solutions. Okay, in this example, we're solving the equation 3x squared minus 4x minus 9 equal to 0 using the quadratic formula. Since this equation is already equal to 0, we don't have to do anything extra to start it. We just have to start by figuring out a, b, and c. A is the number beside x squared, or the coefficient with x squared, which is 3. B is the coefficient with x, in this case negative 4. And c is the constant term, which is negative 9. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now that I have a, b, and c, I can replace them in the quadratic formula and then just start simplifying. So we have negative b, which is negative 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 3, times c, which is negative 9, all over 2 times a, which is 3. I'm going to do the same three things I normally do. I'm going to deal with the double negative to get positive 4. We'll have the plus or minus in the radical. I'll deal with the stuff underneath the radical. So in a calculator or by hand, I'll do negative 4 squared minus 4 times a, which is 3 times -9. And I'll type that into my handout calculator this time. And in doing so, I got 124 when I typed that in. And then on the bottom of the fraction, I'll also take care of that. So 2 times 3 is 6. Now I have to simplify this radical. Unfortunately, 124 is not a perfect square, so I'm going to have to break that down and figure out the biggest perfect square that goes into 124. This is a little bit guess and check, but it just happens to be 4. And it's 4 times 31 to give me my 124. With that, I can continue to simplify this expression. So we'll have the 4 plus or minus. When I simplify the radical, the square root of 4 is 2. And we can't actually square root 31, so it will stay underneath the radical. All over 6. Now because of the radical, I won't be able to combine like terms. So what we're going to do instead, we're not going to separate into the two solutions. We'll just look to see if we can reduce the fraction. And depending on what your goal is, depends on if you want to break it up into two separate fractions or not. But usually we just check, is there a number that goes into all three of these to reduce this fraction? Must go into all three of them, because essentially what we're doing is we're factoring it out of the top term. So like 2 goes into both 2 and 4 on top. So we have 2 times 2 plus or minus the square root of 31 over 6, which then reduces with the 6 in the bottom to become 3. So as long as you know that 2 goes into all three of these numbers, you can just divide each of them by 2 to end up with the same thing, 2 plus or minus radical 31 over 3, which would be the final answer. Just as a side note though, don't forget you can write it as two separate answers. It's just not always done whenever there's a radical, but you can write it as 2 plus radical 31 over 3 and 2 minus radical 31 over 3, just as an alternate way of writing it. In this example, we're going to solve the equation x squared equals 9x minus 27 using the quadratic formula. In order to use the quadratic formula, it must be set equal to 0. So I'm going to start by moving everything to one side. Now, I like my x squared to be positive, so I'm going to make sure to move everything to the left side just because it's a personal preference. So I'm going to be subtracting 9x and adding 27 to both sides, subtracting 9x and adding 27 to both sides. I'm not going to be able to combine anything. There's no like terms here, so x squared minus 9x plus 27 will be equal to 0. So I've moved everything to one side. Now we can figure out a, b, and c, so we can start using quadratic formula. A is the coefficient with x squared. In this case, there is none, so it's implied to be 1. B is the coefficient with x. In this case, -9. And c is the constant term, which is 27. Okay, so I have the quadratic formula here, and I'm going to begin plugging stuff in to the quadratic formula. So negative b, so we have negative from the formula and -9 from our value for b, plus or minus the square root of b squared, so -9 squared, minus 4 times a, which is 1, times c, which is 27, all over 2 times a, which is 1. So there's my initial setup. I'm going to go ahead and take care of the same exact three things that I usually do. Double negative here makes a positive 9. We'll have our plus or minus the square root all over. And then the next thing I usually do is I type the stuff underneath the radical into the calculator. So I'll be typing my -9 squared minus 4 times 1 times 27 into my trusty calculator. which came out as negative 27. And the third thing I end up doing is I type in, or I deal with the 2 times 1 in the bottom, which is 2. The next thing we focus on is the radical. We have to deal with that next. The square root of negative 27, unfortunately, negative 27 is not a perfect square. So we're going to have to break things down. It is negative, so I'm going to separate the negative 1. The square root of 27, well, 27 is not a perfect square. The biggest perfect square that goes into 27 is 9. It's 9 times 3. So if I go through and simplify this, we have 9 plus or minus. For the radical, we have the square root of negative 1, which is I. Square root of 9, which is 3, so we have 3i. And then we can't actually do anything with that last 3, so it's going to stay underneath the radical. And this is all over 2. Once again, since there's a radical, we're not going to really separate it into the 2 separate equations. We should try to reduce the fraction, but nothing goes into 2, 9, and 3, so I know I won't be able to reduce the fraction. So this is it. You may see it written in a couple other forms, including, since there is I, they may also write it as 9 over 2 plus or minus 3 radical 3 over 2i. You may see other various forms as well. But this is probably my personal favorite. It's less extra stuff. Okay, in this last example, we're just really looking at which method is preferred or which method would be the most efficient depending on how the equation is. So I'm going to start with reverse order of operations. Which is also taking square roots. Taking roots. This is easiest when x only occurs one time. So in this first equation, you can see x squared only occurs one time. So that is easiest by taking square roots or reverse order of operations. And then same thing with this third one. Because x only occurs one time, it is easiest with reverse order of operations. This also goes for if you can combine like terms and still only have x occurring one time. Reverse order of operations would be the easiest. So this is already assumed to have combined like terms. Now, next would be factoring. And using zero product property. Factoring and using zero product property is definitely the easiest way to go if it's in standard form without C, because you can just pull out a common monomial and then it's already factored. So the second one here, where there's x squared and x but no C term, is probably easiest done by factoring. This last one, we have one more method, which is the quadratic formula. For the quadratic formula, you can always do it, just sometimes it's not the most efficient way of doing it. For this last equation here, this could be done easily by factoring if it's factorable. Of course, you don't know if it's factorable or not until you try to factor it. I find it easier to do it by factoring if it's indeed factorable. However, that's not guaranteed just by looking at it. Quadratic formula, while may not always be the most efficient, it always works. So that's the different situations that can happen here. I usually try to factor if possible for that last case, and if it isn't factorable, I go to quadratic formula, and yeah, so it's just kind of a little bit of guess and check if x squared, x, and you have the constant term as well is all there. You can also do it by completing the square, rewriting it like this, so you can complete the square as well. But I usually don't complete the square unless I actually need to for a different reason, to just rewrite the equation and identify properties in that equation. So I usually don't complete the square once I talk about quadratic formula. For solving purposes, that is. Okay, so in this last example here, we're going to be looking at actually proving the quadratic formula. So we're going to be showing that ax squared plus bx plus c, if we were to solve this equation, we are going to get the formula, or the answers, x equals negative b plus or minus the square root of b squared minus 4ac all over twice a. And the way we prove this is actually by recreating the quadratic formula, which was done by completing the square. So to complete the square, we start by dividing everything by a. That's the first step in completing the square. In doing so, we have x squared plus b over ax plus c over a equals 0. Next thing we want to do is we want to get the c over a term to the other side. So we're going to subtract c over a from both sides, giving us x squared plus b over a times x equals negative c over a. Next, we're going to do the completing the square part of this, which is taking our b, which is going to be a little bit confusing here. The formula for the completing square is b over 2 squared. It's a little confusing because this b is representing something different than the b in my equation. Now, my b in this little formula is actually b over a here. So when I go to plug b over a in, it's going to become b over a over 2 squared. We'll do keep, change, flip to simplify this fraction. So multiply by the reciprocal, that is, times 1/2, which gives us, multiplying the tops, we have b, multiplying the bottoms, we have 2a. And squared. And lastly, to finish figuring out what we're going to add to both sides, when you square a fraction, you're going to square top and bottom. Since everything's connected by multiplication or division, we'll square each base individually due to exponent properties. So we'll have b squared, 2 squared will be 4, and then a squared in the bottom. So we're going to be adding to both sides b squared over 4a squared. So we'll add b squared over 4a squared to both sides. Which is going to give me x squared plus b over a plus b squared over 4a squared. Before I rewrite the other side, though, I'm going to do a little bit of work off to the side. I'm going to go ahead and simplify this expression, writing it as a single fraction. If I do that, I need a common denominator. So just rewriting it real quick, we have our common denominator would need to have a 4 and an a squared. So the first fraction is going to need to be multiplied by 4a to turn it into a 4a squared. We have to do that on top and bottom for our common denominator. So we'll have negative 4ac on top over 4a squared plus b squared over 4a squared, which turns into, if I write it as a single fraction, negative 4ac plus b squared over 4a squared. So let's bring it down to our current situation. I'm going to go ahead and rewrite these two, just changing the order, commutative property there. So that actually looks like part of what we're actually going for. So b squared minus 4ac all over 4a squared. We're really close to the actual final step of it. The next part in the completing the square, so back focusing on this left side now, is to actually do the factoring. So for the factoring part, because we completed the square following that process, I know its factors are going to be the square root of that first term, the square root of that last term, which is going to be b over 2a, just squaring rooting each of the terms. You also kind of see it right over here, right before we squared it earlier, with the same sign in the middle, so plus sign in the middle, squared, equals our b squared minus 4ac over 4a squared. Let's move it down here. Oops. Okay, so let's move everything up here a little bit, and then just keep going. So according to the property with square rooting the sides here, if we have x plus b over 2a squared, all in parentheses squared, equal to this expression, we can rewrite it as x plus b over 2a equals plus or minus the square root of this expression, b squared minus 4ac all over 4a squared. Of course, when we square root a fraction, radical properties will tell us that we square root the top and bottom separately. So square root of b squared minus 4ac over the square root of 4a squared. And now on top, we really can't do anything with it. So we'll end up leaving it as is when we rewrite our next iteration here. So we have plus or minus. However, on the bottom, we can actually square root it. So we'll have b squared, the square root of b squared minus 4ac on top. And then on the bottom, the square root of 4 is 2, and the square root of a squared is just a. The final thing we'll have to do is finish getting x by itself, and we'll subtract b over 2a from both sides. Subtract b over 2a from both sides, which, if I do this, move it up a little bit more here, we will end up with x equals negative b over 2a, just rewriting that first, plus minus the square root of b squared minus 4ac over 2a. Since we have a common denominator, they would write it as one fraction, so one more iteration here. So negative b plus or minus square root of b squared minus 4ac all over 2a, and as you can see, that is the formula for the quadratic formula, giving us the solutions for the quadratic equation in standard form.